Next, I would like to introduce the next topic, which is regarding a panel talk about enabling PCIe Gen 5 for OCP NIC 3.0 ecosystem. And Samit from Facebook will be the moderator for the panel. I'm joined by a very strong panelists from our NIC ecosystem. We have Robert from Intel, Ricky from HP, Long from Broadcom. Next, I would like to introduce the next topic, which is regarding a panel talk. John from Dell, Wasim from NVIDIA, and Rick from Keysight. Samit, please take it over.
Thank you, Damien. Hello, everyone. My name is Samit Ashtir. So we are here today to talk about, to discuss with our experts here how PCI Gen 5.0 technology was enabled on OCP ecosystem. I'll be the moderator for the panel. Before we get started, I would like to request one of our panelists, Robert from Intel, to share a quick run through of why and how the OCP community defined the specifications to enable PCI Gen 5.
So hello, everyone. My name is Robert Bentley. I work for Intel Corporation. I am a design and signal integrity engineer. And let me see if I can share my screen here. Right. Okay, so this section is a panel discussion for enabling PCIe Gen 5 in the OCP NIC 3.0 ecosystem. Let me see if I can, okay. So an abstract to kind of frame this discussion, PCIe Gen 5 is the 5th generation in PCIe technology. This brings our data bandwidth from 16 gigabit per second in a Gen 4 interface up to 32 gigabit per second. And this enables new use cases such as 400 gigabit Ethernet. So going from a 16 gigabit interface to a 32 gigabit interface really imposes a number of additional signal integrity constraints that both add-in card and platform vendors need to be aware of when they're designing their layouts and their transmission lines. So things like ultra low loss PCB materials is required or may be required, back drilling, micro vias. There's a number of different techniques to improve the signal integrity characteristics of your design, and many of those are required to support the Gen 5 interface and the OCP form factor.
Robert, sorry for interrupting you. You are sharing your presenter screen and not the screen that you intend to share.
Let's see here. All right, can you guys see that?
If you go back, there's a button on the top that says display settings that you can swap the views.
See display settings.
Just go to your, just go to presentation mode again.
I'm not seeing it.
Just the button at the bottom right that you use to put it into presentation mode. No, yeah.
Here we go. Share.
Or I can share, Robert.
There, you want to share? Yeah, that'd be helpful.
Okay, go ahead.
Sorry, apologies about that. I guess the multiple monitor setup isn't working for me this morning. Okay, where was I? So, so those signal integrity constraints are really amplified in high volume applications, which is obviously a target application for OCP platforms. So in this discussion, we really wanted to talk about the process that the group went through to collaborate and ultimately agree on these channel design requirements. So the goals for this Gen 5 enabling work group was to find cost-optimized solutions that would work for both the add-in card vendors and the platform vendors. The PCIe SIG folks set a loss budget for the chem form factors at 9.5 dB for insertion loss. There was a community request to try to decrease that, with the goal being to shift some of that signal integrity burden from the OCP platforms that may not always ship with a Gen 5 add-in card into the Gen 5 add-in cards to try to cost optimize those platforms. So just to kind of frame the discussion, there was quite a bit of technical work that happened on both the platform side and the add-in card side. So this is an example data set that we received from HP. And the initial analysis that HP came back with was essentially that, hey, at 9.5 dB, that doesn't work for our platform design, that it really creates a negative margin condition for the platform. So that didn't work for HP. They came back and said, okay, at 8 dB, we can, we get into positive margin, and that works for us. Dell and Facebook had similar analysis and similar feedback that they provided, and Dell was being a bit more aggressive, trying to decrease that loss budget even more. And the original request was 5.5 dB is where Dell wanted to be. So if we go to the next slide. So at Intel, so my focus has been on the add-in cards. And with add-in cards, it's not as easy to just throw, really expensive, exotic materials at the design. But in doing that, the percentage of our BOM cost is pretty significant when you look at the PCB. So doubling or tripling, or even worse, the cost of the PCB in an add-in card is not really a place where we want to be, because it really makes us not cost competitive. So where I spent a majority of my time is, okay, what optimizations can we do at the board level that we essentially get for free? So things like VN cap tuning, optimizing the Goldfinger entries, optimizing the breakout and escape strategies, and then also taking an opportunity to feed back into our silicon design teams and our package design teams, and seeing what they can do to improve their loss characteristics and make sure that the decisions that they're making align to what the industry is asking for, or what the work group is asking for as far as channel loss. So this is just a quick summary of the data I was able to compile. And at the end of this analysis, we were able to get down to a little over 6 dB for total add-in card loss. Now, given that this is a simulated environment and not verified in measurement yet, we added a manufacturing margin requirement onto that, and we ultimately committed to 6.9 dB of channel loss, and the work group compromised at 7 dB, and that seemed to be a good compromise between the performance expectations that the platform vendors were asking for and cost burdening, with the add-in cards. So that's a high-level overview of the work that this work group has done over the last, I guess 4 to 6 months. And so I guess this brings us into the panel discussion. So Sumit, I'll hand it back to you.
Thank you, Robert. So just now that we have level set ourselves of what this discussion is about, so let's go into a quick introduction of our panelists, who we have. So we have 7 panelists here, and I would like to request from we have the listed names, so I'll just go name by name and request everyone to introduce themselves. So John, do you want to go first?
Sure. I'm John Lewis. I'm a hardware architecture for networking and Dell's PowerEdge server group.
Next is Long. Long, do you want to introduce?
Yeah, my name is Long Win, and I'm a board designer at Broadcom.
Thanks, Long. Next is Rick Eads.
Ricky Lai from Hewlett Packard Enterprise. I am a senior design engineer. Have been doing signal integrity simulation, validation, measurement for over a long time, since PCIe, PCIe Gen 1, Gen 2, Gen 3, Gen 4, and Gen 5 now.
Thank you, Ricky. We have next is Rick Eads from Keysight.
Yeah, hi, this is Rick Eads at Keysight, and I am a principal engineer and program manager for PCI Express solutions at Keysight Technologies. So responsible for transmitter and receive test applications and other tools that we work on here at Keysight.
Okay. And Robert, do you want to quickly introduce again for yourself, or?
Yeah, sure. My name is Robert Bentley. I work for Intel Corporation. I am a design and signal integrity engineer focused on add-in cards, add-in card Ethernet.
Thanks, Robert. And last but not the least, we have Wasim Mashakra from NVIDIA.
Hi, I'm signal integrity engineer, NVIDIA, Melnox.
Cool. Thank you, Wasim. And for a quick intro on myself, I'm a hardware systems engineer, primarily working on the storage systems, but very much engaged in the OCP SI working group. So now with that intros, let's go quickly through some of the and try to help share our experiences with the community, like how the community came together and collaborated to define the loss budget and the working model that we used. So as Robert had presented earlier, so first question is probably for everyone. We can, so the way we can do it is probably a minute and a half to a couple of minutes, everyone to share their thoughts. So this one is for everyone. So as Robert has shared that there was a lot of underlying technical work which went into defining the loss budget. So can you share your thoughts about how the group partnered together to review these technical details, so to effectively define the loss budget? So we can start again by John first and then go through that order.
I think first, with everything in open compute, we went out and asked for, what is the community seeing, both from an adapter and from a system perspective. And, we started out and we were pretty far apart, frankly. Dell was very aggressive. We did want, as Robert said, we wanted a 5.5 dB limit. And I think the good thing of that was that it really kind of energized the group to go and be a little more aggressive. But as time went on and more models were made available, it seemed like 7 was where we were bottoming out. And also that included some margin because we haven't deployed this yet, so we don't know what the other issues we don't know are. And so I think it was a great community effort. It showed a lot of different companies participating, and I'm happy with that result of 7 dB.
Thanks, John. Long, do you want to share your thoughts?
Yeah, sure. So when we first discussed about the loss for the next generation card, so obviously we didn't have any Gen 5 capable boards at the point. So what we did was we took the existing boards we have and we did the simulations with the Gen 5 requirements, just to understand where we're at. Since we have the same form factors, the assumption was that the routing and all that stuff would be very similar. So to understand the requirement, initially there was below 6. The result that we got was between, I think, 6 and 7, maybe 6.5 something. So I'm pretty happy that the other companies like Intel and HP later come up around and also had similar results. So it's give us confidence that the current budget of 7 dB is, I think we have high confidence now that we can achieve it, since now that we have multiple companies with similar results. So I'm pretty confident that it's going to be something that we can create and make in the future.
Thanks, Long. Ricky, do you want to share your thoughts?
Sure. We approached the problem from a high-level system design perspective. We look at the size of the OCP NIC card. We are talking about the small form factor, not the large form factor. We know that a standard PCIe card is a 9.5 inch long and 4 inch tall, and that require 9.5 dB. And comparatively, the NIC card, OCP NIC card small form factor, is much smaller, so that we know that the trace routing should be shorter, and we should be able to reduce the load budget. But we don't know how much. Is that 1 dB, 2 dB from the 9.5 dB? So we have that in mind, and then we look at from the system perspective, where you put down the CPU is near the front of the server, and then the fan, and then the NIC is all the way at the back. And so what is the worst case trace route that we will have? And then the best case routing that we can have if you can see the slide that I have presented, we route it not on the microstrip layer because it has a higher loss. We route it on the strip line layer, just right about the bottom layer, to minimize the weird stuff and reflection and all this. And then from that point on, we kind of estimate from different material that we can choose, and how we can from estimation what kind of material that we can use, and what loss budget we can attribute to the NIC, OCP NIC, that we can have positive margin. We estimate 8 dB, and I'm pretty happy that Intel simulation showed that they can do 7 dB. So that gives us 1 dB of margin, which is we are pretty happy with it.
Yeah. Cool. Thanks, Ricky.
You're welcome.
For sharing your thoughts in there. Rick, do you want to share your perspective, even though you have been looking more from the other side of the testing perspective?
Yeah, sure. So from a testing perspective, looking at it from the view of the PCI SIG, for PCI Express Gen 5, there's a lot of thought that goes into the channel for the CHEM form factor. And so the testing, when it comes to validating the transmitter requirements as well as the receiver requirements, when you're dealing with a form factor specific signal integrity consideration, is directly impacted by any changes to that channel requirement. So if you reduce the overall channel loss or you switch the budget around, we know we have an overall loss function of about minus 37 dB roughly. And while that's not specifically stated in the PCI Express specification, the channel validation is always done with a statistical simulation. So as long as you're able to meet the I width and I height requirements following CSIM-based statistical simulation, then that channel is good. But when it comes, so when you switch the budget, then it becomes really critically important to make sure that you comprehend the PCI Express standard is a die-pad to die-pad measurement. So if I'm validating a transmitter within a given form factor, I want to make sure that when I'm looking at the I width and I height at the end of the channel after equalization, that I'm applying the proper channel. And so while we have mechanisms set up for doing that for PCI Express in the chem form factor, that's something that needs to be considered as you're looking at the OCP form factor. And ditto goes for the receiver test. In the receiver test, we're trying to answer a very specific question, and that is the receiver capable of meeting the target bit error ratio in the presence of a worst case signal, meaning the minimum I width and I height that's allowable in the worst case channel.
Mm-hmm.
And so that's a really critical thing to keep in mind as you're doing receiver testing, that you still maintain that assumption of the worst case channel when you're doing the calibration of the BERT pattern generator.
Sure. Good. Thanks, Rick. Thanks, Rick. Same question to Robert, to you. Like, can you share your thoughts on about how the group partnered together and reviewed these technical details to define the loss budget?
So I think as an add-in card vendor, my focus was a bit different. So the question that I had to answer is not just can we meet this budget, but how do we do that in a way and stay cost competitive, right? So as an added card vendor, cost is a huge concern, especially the PCB cost. So my focus was really how do we get every dB out of that design for, what optimizations can we do for free that we don't have to incur costs for, like going to an ultra low loss material. So what I found the most useful thing throughout this collaborative process has been working with John and Dell's signal integrity team and really challenging all of the assumptions that we were making in our design and going through them step by step with the Dell signal integrity engineers, and just make sure that we're on the same page about the assumptions we're making with how we're doing, how we're doing our via transitions, how we're setting up our caps, really figuring out where every, a tenth of a dB here, a tenth of a dB there, it all adds up, and that's. I found that incredibly useful to sit down with the Dell signal integrity engineers and really work through those assumptions line by line. And I think without this forum, I don't think that would have happened, or at least not in the way that it did. So
that's nice to good to hear that. Thanks, Robert. Wasim, same question to you. Like, can you share your perspective on how the group partnered together?
Yes. Okay. For me, it's the same. It's the loss budget impact the materials. For this current design, I use ultra low loss material, so it's 7 dB is achievable for us. But if you want next year maybe to do low cost, it will be hard.
Sure. Good.
For now, it's okay, 7 dB.
Good. Thanks, Wasim. So, so this is helpful. So going to the next part on a similar theme, so as we kind of understood, this was really a community collaboration with participants from competing organizations here. So this question is for everyone. Would you please share your thoughts about how you balanced not only collaborating across the competitors effectively, but also ensure a feasible solution is achieved? Again, probably give a minute and a half to 2 minutes to share your thoughts. This time we can start from the reverse. So Wasim, do you want to take a quick stab at it or share your thoughts?
I built all the channel from the package to the PCB. all the VIA, decap, I do all the SI work, and I didn't see, it's not, was very difficult to get the 7 dB because I'm already using very good materials for this project. What else do you want to know?
Do you want to share some thought, like since there was a lot of technical insights in there, we have people, participants from participants from different companies coming together, which are kind of competing for the same product. Do you have any thoughts there, like how this community effectively collaborated in that area?
Okay.
All right.
I don't know what to say.
Okay, that's fine.
I have nothing to say.
Yeah, that's fair enough.
Yes.
Robert, do you want to share your thoughts on how did we balance sharing these technical details while we are working with these competitions around?
Yeah, so I think working with competitors is always a challenge, right? So you have to think about how to frame these technical discussions, at a higher level without really giving away your secret sauce, right? But I think as a work group, I think we worked through that, and we all had our own data sets to look at, and coming to the group and really coming to a consensus about what's achievable and what's not. From my perspective, one of the main challenges that we had was getting our silicon design teams and our package design teams in alignment with the direction that this work group was heading, right? Because when you look at the SIG budget of 9.5 dB, well, that's a ton, right? So if your silicon is taking up half of that budget, that's not a big deal because you can still meet that budget in a board design. But when you move to the OCP form factor, that becomes much more challenging. So one of the big challenges that I had was getting our silicon team in alignment with the requirements that we need at the board level. And that alignment really only happened because of the work that we did in this work group. So I think the outcome was really good.
Thanks. Thanks, Robert, for sharing that thought. Ricky, do you want to share your perspective on how kind of you help balance some of these technical details with while the competitors in there?
Sure. I think we need to be open up and don't put on your head as, okay, I'm system guy. I try to get as much margin as I am possible so that I can use the cheaper material. We need to think of, okay, what is more realistic for the industry to enable both the system guy as well as the editing card. They have a reasonable amount of budget for them to come up with a cost optimal design. So we sharing our knowledge from the system side and with different material. Hey, guy, we're not trying to steal your budget. This is what really is, and so that hopefully we can come up with a consensus, and we did, so which is a good thing.
Thanks, Ricky. The same question for Long. Do you want to share your perspective on balancing some of these technical insights with the competitions?
Yeah, sure. I mean, when we talk about technical information and across multiple companies, I mean, it's I think all of us understand that we can still share technical details without sharing any IP related stuff. So it's great to have this group working together, still discuss technical aspects of system designs, adding card designs, and still collaborating in an open setting. And exactly what happened. And it's great to have system engineers and adding card engineer in the same panel so that we can talk about the whole system. In the past, it usually just system companies defining or give out a requirement, and here, this is what you need to meet. But in this setting, it's great to have company like Intel, Facebook, Dell, for example, saying, hey, can these companies that are making adding cards, can you guys meet this? And it's great to see the amount of collaboration and the work that we did, with all the simulation and data sharing. And I think it's great. I mean, it's, I think we're going in the right direction.
Thanks. Thanks, Long, for sharing your thoughts there. I think there's John has to take a little bit, has some sidetracked. So Rick, now you're back. Let's see you're back here. Sorry, I skipped you earlier. So you have been engaged with the PCI SIG also, and you have been very actively involved with this group also as we were developing this. So do you want to share your thoughts on like how your perspective, like how we collaborated while we share, like all these technical insights were being communicated across the different companies?
Yeah. So I think that the collaboration is a critical component to achieving success. And when you think about what does success mean with a standard, I think it can be summed up in terms of really reliable interoperability. And we haven't always had that in the industry. While we have had standards, for example, there are some groups that develop standards, but they don't really focus on the end goal, which is to achieve interoperability. And so they write a standard, but they don't focus on how do you go about providing a consistent way to test it so that one vendor, like in our case, that's developing a root port or root complex motherboard, is able to operate independently to the point where a customer can reliably buy their motherboard or buy their server and buy another vendor's NIC or adding card and know with a high degree of certainty that plugging those together, it's going to work. And what this has led to in the past has been that, system integrators end up cherry picking specific products. And it's worked out much better within the PCI SIG where the organization has gone to the task of writing test specifications and done a lot of work through volunteer efforts of the members to really put together a full compliance program that helps to ensure that the industry knows what they're going to have to meet in order to achieve interoperability. And that, I think, has perhaps more than anything driven the success of PCI Express as a standard through billions and billions of ports. So it makes sense to me that within OCP that the group follows a similar process wherein there's collaboration and a focus on the fact that interoperability starts at the physical layer, paying attention to that, and then moving on beyond. Because that creates the best opportunity for the ecosystem and customers in general.
Sure. Thank you, Rick. That's very helpful. So now going to the next one. So this is more for the NIC developers, actually. So as Robert shared earlier, presented in the overview, so one of the goals was to optimize cost for the platform, or in other words, burdening the NIC with additional constraints. So for the NIC developers, can you share your thoughts on the challenges you face to balance this community request and overly constraining NIC from cost, development complexity, and internal engagement perspective, like working with your internal teams? So we can start with Long first.
As I mentioned earlier, I mean, when we saw the new requirement, we had concerns that maybe we have to go to very expensive material and so on. And so require us to do some detailed simulation to make sure to see where we at. So like I say, we didn't have Gen 5 capable PCB that we can rely on. So we had to make a lot of some changes and optimize a few things. So it does require us to do our diligence to understand what the requirement is, and with the 7 dB, that does give us some margin, and it doesn't really, and we're confident that we can achieve it with not too expensive material. So with these kind of requirements, it's put a lot of emphasis on simulations ahead of time, just to understand where we're at the same time, we also have, the PCIe Gen 5 spec that already sort of mature, so we can leverage a lot of things that they've done in that spec, just to gain, 0.1, 0.2 dB here and there. So all that adds up. So these are the stuff that we sort of kind of ignore in the past, since it's kind of not, we have more margin than we used to have. So, but now we have to pay attention to all this stuff, and whatever we can gain from a design perspective, like optimize any kind of geometries and things like that, so that we don't have to go to a really expensive material just to compromise for those things that we usually ignore because it's minimal. So it makes us design better boards. Actually, it makes us aware of channel loss completely from end to end. So
thanks, Long. So same question for you, Robert. Can you share your thoughts on the challenges you faced to balance this overly constraining requirements on the NIC and with your internal engagements?
Sure. So in addition to signal integrity, I'm also a design engineer. So I'm also responsible for getting actual product out the door and on the market. So cost is a really important aspect of our designs. So things like silicon cost, power delivery cost, I don't have a lot of control over those things. But when it comes to the PCB design, that is where I can, apply quite a bit of influence from the work we do on the signal integrity side. So, my focus was really how do we get to into solution space without throwing exotic, high-cost materials at it, because going to a really exotic material that really puts us in a place where we're just not going to be cost competitive in the market. So my focus was optimizing our layouts and our assumptions, and really challenging all of the best known methods that we had been using in previous designs, and really starting from scratch on what we think we know, especially going up to a 16 gigahertz fundamental frequency. That it kind of changes things. So a great deal of my time was spent figuring out what materials are going to work for us that are just good enough to meet the community request to lower that loss budget, while balancing that with the cost targets that I have to drive to. So I think the collaboration that this team worked through really enabled us to get to a place to where we could get where we could meet the request of the platform vendors while hitting cost targets that are going to work for us when we get product out the door. So
thanks, Robert, for sharing that perspective. Same thing, Wasim, do you have something to share on your end about the challenges you may have faced, like to surface these overly constraining NIC requirements, and how do you balance the cost, the development complexity?
Okay, I feeling the same. I have a challenge to make all the optimization, or to choose all this right stack up, traces, everything, every detail in the channel. It was difficult to choose. It's not only loss, it's also crosstalk, everything to consider. Add the package, ball out, PCB together.
Thanks, Wasim.
Okay.
So on the other side, so talking about the platform side, so considering the request from the platform developers was to increase the loss budget on the platform side. So as a platform developer, so this question is for the platform developers. Can you share thoughts on the motivation and trade-offs that were considered as the community requested to reduce channel loss on the NIC side, while we increase the budget on the platform side? So we can start off with John.
Sure. I mean, one of the challenges for PCIe Gen 5 is that you've heard Robert and Wasim and Long talk about exotic materials used on NICs. Well, those same exotic materials cost a lot more on a system board because the size is so much larger. And so what we needed to do was to balance with the NIC suppliers the cost of the solution to the end customer, and not just worry about what does the system board cost or what does the NIC cost, because in the end the customer has to buy both to get the feature. And so the secondary item is that for Dell's hot aisle servers, this is pretty much as far away from the processor as you can get, and it is an attempt to not use any type of redriver or retimer in the path. So that's what we started with as a goal, and then we developed our channel based on the 5.5 dB that I mentioned earlier. But we knew that that's probably very aggressive. But we do know it's possible. We have our own cards, but it's not possible across the board. And so in working with the group, we were able to get something less than what PCIe SIG had for their adapters, and really drive the solution for the end customer, given the constraints of the OCP card, which are slightly different than the PCIe card. So that's kind of the thought process we went behind, and really how the OCP subgroup helped in determining what the end result was.
Thanks, John. Thanks for sharing that. Ricky, do you have anything to ask? Do you want to share your thoughts in there?
Sure. If I just put on my engineering hat, we can do anything. If cost is not a constraint. But everybody understand, particularly in this marketplace, cost is a constraint for everybody. So we just try to do the most reasonable things. I remember many years ago when PCIe Gen 3 first got on the market, we designed with many different channels with retimer and redriver to, because of scale about the loss requirement. But then there are all other challenges. You can save the cost of the PCB, but then the BOM cost for the redriver, retimers, and also the associated complexity of the layout, the design, the support, different endpoint device, they require different setting. Yep. So you end up to be, you have to keep on tuning your redriver, retimers for different endpoint even after you get into productions. Yep. So yep. those hidden costs is difficult to account for, but it takes away the engineering time to develop new products. so that we, similar to John, we focus on the channel that is totally passive. It's much easier to manage, to see if we can get down to the budget. Even if you see from my slide, we use the very low loss material. The cost is comparatively more expensive than the mainstream materials. But we think that as Gen 5 system get into productions, as the volume is increasing, then the PCB cost will go down. That's what we have been seeing in the past. When Gen 3 first came out, we used more expensive material, and then after a while, it's getting cheaper. But if you try to design a channel with a retimer, redriver, you tend to be stuck with a single vendor, and that cost did not go down even after you go into production. It may go down a little bit, but not as much as a PCB.
Yeah.
So we try to focusing on get a solution with a pure passive channel first.
Yeah.
And that's the way how we approach the problem.
That's good. Thanks, Ricky. Thanks for sharing that. So I just got pinged, like I think we have 10 more minutes here. So I would to go to, so this question is for Rick. I think Rick, you touched base earlier about the, from the testing perspective, but I wanted to actually get a little bit more specific onto the OCP NIC ecosystem. Now that we're deviating away from the PCI SIG ecosystem in terms of the channel loss. So question for you, Rick, here is, can you share your thoughts on how this deviation impacts electrical interoperability testing in terms of test methodologies, acceptance criteria, so that we can enable Gen 5 on the OCP ecosystem? So if you can have like a minute or so, that would be really helpful.
Okay, and the terms really matter here. And you mentioned, how does this impact interoperability testing? When you think of whether a device is compliant or not to the spec, interoperability testing is half of the equation. There's compliance to spec, which is typically cast in terms of compliance to transmitter requirements, receiver sensitivity requirements to jitter, and protocol requirements. So those are all elements of what we would call compliance testing, right, of the device. And then a second from that is interoperability. So in terms of interoperability testing, what that comprehends typically is you have a number of devices that are there or that you have available to you, and then you plug them in to see if they interoperate. And within the PCI SIG, our compliance standard is that a device is deemed compliant if 8 out of 10 devices attempted actually interoperate as expected in the device. So by any deviations to your form factor, as long as all of the devices comply with the form factor, you would follow through with the interoperability testing the same. So in the same way. I think what you're really getting at, though, is by changing and adjusting the channel, how does that affect the compliance testing for transmitter, receiver, and protocol? And that is something that really your members should probably contact their test vendors on to get some specifics. Within our tools, for example, we have both a CHEM standard that we implement, we have an M.2 standard that we implement, and we also have a more flexible environment called the debug environment. And so within the sense of being able to enter a debug mode for a given test tool, you're allowed to make adjustments as to how the calculation is done for what is deemed passing or failing. And you can also adjust some of the pass-fail criteria. So those things are within the realm of, fall on the shoulders of the people who are attempting to run the test within a different form factor than what is officially covered for PCI Express and the PCI SIG.
Thanks, Rick. Cool. So before, I think we're almost 5 minutes into, almost 5 minutes in there before we are done with our session, but So before we open up the Q&A for the attendees, so one on a closing question, one from the panel, this is for everyone. Could you share one thing which you think that went well that the panelists would like to share the experience with that, like with the rest of the attendees in this whole engagement and defining this loss budget and the collaboration? Can you share your thoughts? So we can start off with Wasim. Wasim, you still there?
As was in mute. You can repeat the question?
Yeah, I just wanted to get your thoughts. Can you share one thing you think went well during this exercise of defining this loss budget of enabling PCI Gen 5 into the OCP ecosystem? So in a minute or so.
Okay, it's good to hear everybody what they think about the loss budget. I think I have the same problems. I don't know what to say else.
That's good.
Okay.
Robert, do you want to share your thoughts? One thing you think which went well in this whole?
Sure. You know, at a high level, I thought the whole process was really good. So Sumit, I really have to, you know, extend appreciation to you for bringing this group together because, you know, I think the openness and the knowledge sharing that the whole group approached this problem with, I think, is really what enabled us to be successful here. So, you know, I wanted to thank you and certainly the knowledge sharing that that John enabled at Dell with his signal integrity team. That was critical for us to get to where we landed. So,
Thank you. Thanks, Robert. Thanks. I appreciate your thoughts there. Rick Eads, Rick, do you want to share your thoughts? What do you think went well during this process?
Yeah, let me unmute my phone. So overall, I think, you know, frankly, your leadership in driving this is probably one of the main contributors to the success of the program. So I do appreciate that. And your ability to bring folks together with a varied level of expertise helps quite a bit in us being able to identify the issues that we want to resolve, working essentially through a punch list, and then finding folks that are willing to contribute. Because ultimately, any endeavor like this is really dependent upon the volunteer efforts of those who are signed by their companies to participate.
Thanks. Thank you, Rick. I appreciate that. Ricky, do you have some thoughts to share? One thing you want to share, like what went well?
I think everybody opened up and talk candidly about their problem and really willing to find a solution that to achieve a common goal. I think we got a pretty good synergy in this working group.
Thanks. Thanks. Nice. Good to hear that. Thanks, Ricky. A quick thought from you in 30 seconds.
Sure. I mean, the key word here is a collaboration between companies, and it's great to see that. And it's also, we have industry leaders and you have decision makers here that can, you know, help us with the, for example, John, but he's always volunteer to make these test fixture for us, not asking us for a deposit. So that's great. So you have people that can pull the triggers, make the decisions, and you have, you know, all the right players in the team, and it's easy to come up with a requirement because you have people that do simulations and you can do test fixtures. So those are the things that make it great in this setting, and I'm glad to be part of it. And I appreciate that you take the lead in keeping the group together. We all know how hard it is to even make it work people within the same company, right? And this is, we're talking about different companies. So it's great to see that.
Thanks, Long. So John, quickly from your end, quick thoughts. I think we are almost at the time.
Sure. I just wanted to say this is a great group of people to work with. You've been able to bring together the right people. You've got test equipment vendors, connector vendors, board vendors, system vendors. And, you know, as Rick said, that really helps, right? And your leadership there. I think it's also important to realize that, you know, the group has brought in UNH-IOL, and those, the test fixtures are available for them, from them. And so it's really enabled the entire community to benefit from just what a small group of people have done, and go for, you know, the compliance type testing that Rick was referring to earlier.
Yeah, thanks, John. And we are almost at the top of the hour. And just as a closing note, so we have call to action. So like as John was just mentioning, so we have some of the fixture development work which is going on for this interoperability. So if you are interested, please join the group. And there's still a lot of work needs to be done there to help finalize this interoperability testing. And we definitely would like to get more thoughts from the community. With that, thank you everyone for participating in the panel. And it had been really great working with you all. So much expertise out there. I think it was really very educational and informative for me also. So I learned a lot. Thanks everyone. And we'll continue all the good work in the working group.